Okay, good morning, everyone. So, today is the second day of hackathon, and I would like to invite, I would like to introduce you to our speaker of the day, who is Arsh Goyal. Arsh is an SD intern at Goyal. He's a final year undergrad student at NIT, Jalandhar, pursuing BTech in ENTC. He was also an SD intern at Samsung, data science intern at Bitgrit, and software intern at ISRO. He's a branch topper in his college till now, and he has been DC lead at his college from 2019 to 2020. He'll be talking about ML for beginners. And with that said, let's start with our session.
Thank you so much, Asta, for the introduction, and I'm very grateful for the team for inviting me here for this session. So I would like to begin with the session. Thank you so much, Asta, and the whole team of DSC BVP. Okay, so I would start by presenting my screen. If that's visible, please let me know. Does it seem fine?
Yeah,
Perfect. Okay,
perfect.
cool. Thank you so much, Astha. So, just to give a brief about what we are going to learn today and what is this session all about, I am here I'll be sharing one pre-workshop survey form that is to be filled by everyone who is attending this workshop. I am sending the link for this pre-workshop survey form in the YouTube live chat from my handle only. Uh, so I request all the participants to please fill these pre-workshops and post-workshop forms so that you'll be eligible for getting certificates from Google itself for attending this Explore ML workshop, right? Uh, so I request everyone to kindly fill in this form. It's a general form that will ask you about your expectations from today's session and what current knowledge you have about ML, and how you will be like going through this 1 hour and what all things you will gain in this 1 hour. Then we'll share one post workshop survey form, and that post workshop survey form you'll record your responses, and on the basis of those responses you'll be eligible for getting certificates from Google, right? You'll be getting the certificates directly on your mail as soon as after this workshop finishes within 2 to 3 weeks. So let's begin with the session today. Let me see the number of as I would like to mention that mostly these kind of sessions are to be done in a physical space where people are there and we can interact with people and we can have more and more interaction and inputs from people so that we can learn the things together. But due to the current platform, it does not allow us to be in much interactive way, so I'll not keep the mode of communication as much interactive because it won't be feasible, and we'll be going on with the slides. And I believe, I hope, like whenever I ask you to pause in between and think, so please take your time. You can pause your video, and if somebody is watching after this session, you can pause your videos and you can get to know, like you can think on, then try to answer and see the correct answer. So this is something that I wanted to mention, and like this is a bit of what is all about today's session. So this session is basically for very beginners who are not introduced to machine learning. They don't know what is machine learning. They're not aware of the basic algorithms of machine learning or the practical applications of machine learning. So we'll cover all these things in next couple of minutes, and hopefully you'll be getting to know some better insights into what is machine learning and how we should go about proceeding with machine learning algorithms, and how we should start with data science. So, not taking much time, let me introduce myself. My name is Arsh Goyal. I'm currently pursuing my Bachelor's of Technology in Electronics and Communication at NIT Jalandhar. I'm a final year undergraduate student and I have been a software engineer intern at Samsung. Currently, I'm interning at CodeChef. Previously, I have worked in various data science and machine learning domains. I have been an intern in data science at Indian Space Research Organization, that is ISRO. I have also worked with a startup of Japan. It was named as Betgrid. So there also I was a data science intern. So to begin with the session, let's. I hope all of you are ready with the session, and like you might have filled that pre-workshop survey form that will enable you to. That will enable us to improve our program better, as well as it will be help. It will help us to notify you with your certificates at the end of this series. So moving on, yeah. So just to begin with, I would want you all to think like all of you might have heard the word what is machine learning, what is artificial intelligence, how we can relate both of these things, and how the things should be moving. So how you are defining machine learning. So basically, this is what I am here with. We are here with the video that will give you more insights into what is machine learning, and after that we'll discuss upon how you can define it in a better way and what exactly does this mean.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognize a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organizing it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
So I hope you got some better insights into what is machine learning. So basically, machine learning is a specific field of artificial intelligence where a system learns to find patterns and examples in order to make some certain predictions. So computers learning how to do a task without being explicitly programmed to do so is machine learning in general. Let's move on to the next. There's a small activity for you all. I would not recommend doing it right now because it will take a lot of time and it's not an interactive session, but I wish you all of you to kindly go through what this activity is. Go to g.co/quick draw and you will get to know some special games that are related to machine learning, like how your computer is recognizing certain patterns. So exactly what this game does is it will ask you to draw a particular picture. For example, to draw a picture of a shoe. So a picture of a shoe can be anything, like whatsoever comes in your mind. It can be a flip flop, it can be a normal shoe, it can be a casual shoe, it can be anything. So how your brain interprets a picture of a shoe and how are we able to recognize it as a picture of a shoe. So this is something that is the major principle that runs behind machine learning. So machine learning is used in a number of growing applications, though it is not a replacement for every task. I would say in this activity You'll explore an example of machine learning, enjoy the activity, and see if you can form a hypothesis or an evidence based theory on how it works. We'll use this to develop an understanding of how machine learning works. Open your internet browser on your computer and go to this link. Uh, we'll just move on. Yeah. So what does this game, how does this game work actually? I would want you to try upon this game just for a couple of minutes. So go to your browser and search g.co/quickdraw and you'll get to see something amazing. As soon as you're done, please inform me in the chat window of YouTube, or we'll move ahead with the next 1.5 minutes. So I believe all of you might have uh, like gone through what exactly this game is and how we should move. So I want you all to think upon these questions for a while. Like, how does this game works? How is it recognizing your drawings? And further, like, how we can program this thing? So I want you all to think upon this, and then we'll discuss. Right. So here is a clue on how this game works. There's a large amount of data that is used to teach this game how to recognize images. Like if you go to g.co/quickdraw, you can see a lot of examples for an object. In the slide, there are some examples of carrot, right? So if you are going to describe what a carrot was to someone who has never seen a carrot before using only these images, how you would describe it? So you can describe it in any way, like it's of this size, it's of this color, it's of this shape. These are some of the parameters that will go about and like describing carrot using images. Like it can be of the shape of triangle, or the characteristics such as it's a leafy root, or on top, or on lines. Like it can be anything. Like the description depends upon from person to person. So these are some of the images of carrot, for example. So so you're already familiar with the traditional programming where you start with your goal, write logical rules, and redefine your testing until it works the way you want it. So traditional programming, every one of us knows, like we're using loops, we are using if-else operator, we are using certain other programming functionalities to define our, for example, like if an object height is greater than 10, then do this thing. If the object color is blue, then do this thing. So if-else statement. So this is general way of programming, like the traditional way of programming that we have been doing for so long. We have been doing uh, questions on coding, so that involves traditional way of programming. So imagine if you're trying to describe a carrot the way you just described using traditional programming, such as on those like shown on the screen. So this approach would get very complicated, especially if you wanted to account for all the possible ways one could draw an object, because there can be a lot of parameters. So I guess a rule-based approach won't be very sufficient in this case. So how machine learning helps us in this case. So let's discuss. Now, machine learning is an alternative approach to building software. Instead of programmers creating the rules, a model is trained with examples, like you can see in this current picture. Rather than trying to define for a computer what a carrot is and account for all the possibilities, the computer is given lots of varying examples, like you saw in the quick draw data, and told that this is a carrot, this is this kind of carrot, or it depends upon the characteristics of that carrot. So this approach results in more flexible understanding, and like at this point of time, I would like you to think upon what might be the limitation of machine learning approach. So just pause for a minute and think upon like what can be the negatives or what can be the consequences of this machine learning approach. Yeah. So the machine learning model is only as good as, for these examples, for example, if all of these examples are triangle shaped, then it might fail to recognize a rectangular shaped drawing as a carrot. So what type of task you would think, I would like you to just ponder upon and think upon this situation as well, like how you would go, like what do you think would be a good fit for machine learning, or like what kind of examples machine learning works upon. So now you are aware of what is rule based approach and what is machine learning approach. Now we'll discuss some of the examples of rule based approach and machine learning approach, like how they are, these things are working, uh, and how you can move about classifying things on the basis of uh, rule based approach or machine learning approach. So let's move on to the next slides. I hope you're enjoying the lesson, and if you have any queries, you can type in the chat box of YouTube live, and we'll take those queries at the end of the session, right? So the first thing is alphabetizing a list of song titles. So what kind of programming approach does it use? Take a minute and think upon the approach, then we'll get to the answer and we'll discuss upon what actually the answer is. Just think upon it. If you are on YouTube live, you can write it down in the chat box as well. So the answer here is traditional or rule-based approach. Why traditional or rule-based approach? Because these are just the sorting algorithms or sorting rules that are well suited for this task. Like there are fixed number of letters in an alphabet, so there are only so many rules one would need to write. We can just sort the things ahead, and there's not much complexity in rule-based approach involved. So rule-based approach would be better for this kind of question. Next is ranking web search results. So what will be the suitable approach for ranking web search results? It can be both as well. It can be rule based approach, it can be either machine learning, it can be both rule based and machine learning. So whatsoever works perfectly, we will go with that approach. So try to think upon these things, and maybe I believe that you all must be pausing this in between and thinking on what actually could be the answer. So in this case, it would be both rule-based approach as well as machine learning approach, because the approach would depend upon your goal. Like, are you ranking the web results based upon relevance to my query? If the query was news, you might also wanted to take into account how recently the article was posted. So it can be both rule-based as well as machine learning approach. Now comes predicting house prices based upon location. You have a particular location and you want to guess what can be the price of the house here. So this is something really complex, and you might be getting to think, uh, can you use normal programming to know whether we can predict the house prices based upon location? So no, the answer is no. We'll be using machine learning approach in this case, because there's no perfect formula on determining how much a house would cost based upon its location. There are other factors also that could play a part in how much the price costs. So answer is machine learning approach. Next is processing online payments. Think upon it as one of the, like, generally payments are one of the, like, it's a straightforward logical process. It is possible for a programmer to confidently program, like, how to get to, like, exact steps that are necessary for processing online payments. So it is again a rule based approach. If we are thinking about fraud detection, like whether a credit card number was stolen or used inappropriately, is much more complex and hard to define. Machine learning could be used in that case of fraud detection. But as far as processing online payments is concerned, so rule-based approach is considered to be the best approach. Classifying an object in a photo. Classification is one of the important and examples of machine learning. So again, for this example, we'll be using machine learning approach. So, so now you have seen certain examples where we use a rule-based approach and where we use a machine learning-based approach. So just to differentiate between both of them, how these things are different from one another, and how we can classify a rule-based approach from classical machine learning approach. So these are certain differences. So in rule-based approach, rules are already defined, and machine learning approach, it learns from the patterns from the data. Also, improvements come from algorithm and network. Here, improvements can be from additional data. So each has its own benefit. Like in some cases, rule-based approach is more preferable. In some cases, machine learning approaches are more preferable. So this was all as far as your introduction to what is machine learning and how we can differentiate between machine learning approach, how we can differentiate between a rule based approach and machine learning approach. Next, we are coming up with the idea to implementation, like how we should go about implementing these things, and like how we can do it in a better way, right? So again, I'll be presenting one more video, but like while machine learning offers powerful new opportunities, implementing a machine learning system can be really more complex than a traditional software, right? So this is primarily because why machine learning system is only as good as the data is trained on. In this section, I'll provide an overview of the process as well as important considerations, right? So again, there is one video that will help you with how you can implement machine learning.
Suppose you have a great business idea and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has three phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data, other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into three sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like.
Machine learning specific maintenance could include testing other models and settings to see if performance improves.
So this was something that I believe would have made you more clear how you are implementing things, how is the data model, and how are you modeling the things. Moving upon to what is the most important thing, that is the machine learning cycle or the machine learning process. So machine learning begins with the needs of the user and the business. Like with this in mind, you can define an objective so you know how to proceed. Examples could include like predicting which friends a user is likely to share a photo with, or suggest the user what should he eat in a new city based upon the restaurants that have visited in the past. So these are the goals which we should articulate success metrics as well. Machine learning models learn from examples, so it is essential to find a large existing source of data that is relevant to your problem. Like experts say, like collecting, cleaning, exploring, and other data processes tends to be the longest and the most critical part of the process. Like in this also, if we focus on the user, define objective, collect data, train, test, and model, predict, and evaluate. So the major portion of the machine learning cycle is collecting data, cleaning data, exploring data, and other data processes. Like I would say it's around 70 to 75% that in a machine learning process goes into collecting and exploring data. Rest is just 25%, that is predicting, evaluating, training, testing model, right? The arrow pointing back from prediction to the data shows the iterative nature of ML. Like you'll need to refine your model and perhaps your data collection and processing based on the feedback until it is achieving the results you're looking for. Uh,
Let's play a game. Close your eyes
yeah.
and picture a shoe.
This is something really very interesting. So humans are prone to trust results from a computer. Like we assume that a technology will work as designed until it breaks. So however, even a well designed machine learning pipeline can experience issues when it picks up on the biases found in the data form. So this is a very interesting video, and I want all of you to please watch this video carefully. Then we'll discuss.
Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias.
Sorry to interrupt. There was some issue. Yeah.
Let's play a game. Close your eyes and picture a shoe. Selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
Yeah, so this is something that I believe that you have got some better insights into what I was trying to say. So I would just want you to think upon these particular questions and have some answers in your mind. Like when someone describes to you a new application of machine learning, what questions would you ask them based upon this video? Like what approaches could a software development team take to mitigate bias in this machine learning system, like selection bias, latent bias that we have discussed? Moving upon to the next slide. Uh, Again, it's a pretty useful video that will help you gain some insights into machine learning. It's based on ML privacy.
Machine learning systems require lots of data to make successful predictions. What happens when that data is sensitive, such as people's names, credit card numbers, or medical histories? Sometimes, sensitive data is needed to train a model so it can make accurate predictions. But at the same time, this data must be carefully protected. This is the challenge of machine learning privacy. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis the common cold, whereas someone else with the same symptoms plus a high fever might be diagnosed with the flu. Plenty of other factors might influence the diagnosis too. Does the patient have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people and their symptoms, medical records, and demographic information. This data includes plenty of personal information that needs to be kept private. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card numbers used to pay healthcare providers. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your data sets that may be sensitive. For example, people's names, addresses, telephone numbers, email addresses, government ID numbers, and other personally identifiable information, or PII, should be kept private. Another type of private information is user-generated content, such as email messages, YouTube videos, blog posts, and any other content created by known individuals. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to use the data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, you build trust with users and protect your company's interests.
So, as this video mentioned, that privacy is the major concern of machine learning. So, gathering and selecting only the data that your ML system needs to achieve its goal. The less data that you have in the first place, the less you need to protect. So, this might seem like a common sense, but it takes a lot of effort. Stripe away data that your model doesn't need. Always, like, there are various laws, there are various company policies that regulate how data must be kept private. A machine learning products need to be compliant with every country it has customers and users with. So I hope you got better insights into how you were claiming the data, how is ML privacy linked with the things. So now moving on to what can ML do. So it's easy to look at the examples of machine learning and see that it's magical, but it has a lot of new possibilities with technology. We already considered for certain situations whether ML was necessary. So in this section, we'll discuss what type of problems ML is best suited for. You might have heard of these three terms: artificial intelligence, deep learning, machine learning. So just to give you a brief about what all these things are, so artificial intelligence is basically defined as the technology that appears to do something smart. This can be anything from a program software to deep learning models which mimic human intelligence. What is machine learning? Machine learning is a specific kind of artificial intelligence, but rather than a rule based approach, the system learns on how to do something from examples rather than being explicitly told to like what to do. What is deep learning? Deep learning is a specific type of machine learning using a technique known as neural networks, which connects multiple nodes together to solve even more complex type of problems, right? So deep learning, similar to other ML models, learn via examples. It's unique because it connects models to other models in layers in order to handle more complex types of data as like these images. So these are the terms that have been used interchangeably, but to go into the exact things, we'll say that these are subsets of each another. And again, what is ML composed of? The key algorithms powering machine learning were formulated even as much as centuries ago. They come from the disciplines like statistics, linear algebra, biology, physics. So for the last few decades, sufficiently large amount of data were collected to train models, but they were of low quality and expensive to train. Lack of progress and prospects led to an AI winter where ML was considered as a waste of time. In the last few decades, the availability of a relatively cheap and fast computing power have enabled complex calculations across large sets of data necessary to train highly accurate models. So these three compose of and combine to give us what machine learning actually is. So now moving on to some of the very famous algorithms of machine learning, and then we'll discuss some of the examples based upon these algorithms. So first of all, the most important common application of machine learning is classification. So what does classification means? The system determines like which class or category an example belongs to. The output can be a label or it can be a percentage of confidence. For example, if the classifier was trained to identify whether or not an image was that of a lion, it might output yes or no. However, like if we it was more generically an animal classifier, the output could be a lion or a tiger. So classification systems, I would say it depends upon the threshold set by the human developers so that system can distinguish between cases that might be less clear. So if you built an email spam classifier, it would be necessary to fine tune the threshold so that your system didn't incorrectly label an email as spam when it was a genuine one. So you might be seeing in this example also like how we can classify a line. Next is the regression model. So as much as classification is important, so regression is also similarly important. So whenever you want to predict the price of a particular house on the basis of its location, so regression helps there. Like it takes into account various certain parameters and give us a certain result. So regression system outputs a number of examples, how long it will take to drive from point A to point B, or the likelihood that someone will click on a particular ad that is shown on a particular website. So regression systems can be as simple as drawing a line as you see above, or it can be more complex models depending upon the number of multiple variables. You can see in these examples, we'll discuss upon certain examples, it will get to you in a more better way and you will you'll be more clear with what I'm trying to say, right? Next is clustering. So what is clustering and how it is important? Clustering is one of the other applications of machine learning, is determining how closely related items are to one another. Like in this slide, the data of handwritten images is moved into clusters of the same number. Like ones are moved with ones, twos are moved with twos, and so on. Like even within clusters of same number, the images are further clustered by those which are similar in shape. For example, some twos and sevens may look similar. So this is like we are clustering, we are combining similar things together. This is known as clustering. Next is sequence prediction. Like this is the common example that you have seen every day when you're typing, when you're chatting with your friends. Like in order to assist users, it can be helpful to predict what like they might do next. So this could be a prediction of next keyboard key a user will select, as you see in the screenshot. This could be used to propose a spelling correction or suggest replies to a text message. Other examples of sequence prediction could include the next video a user might want to watch or a next stop on a vacation. This is also one of the important aspect of machine learning. Next and the most new advanced concept is style transfer. I would say style transfer or generation. It involves training a model on one set of data and then applying that model to something completely different. It could be as seen in the example, like remaking photographs to look like another piece of art, or translating a voice from male to female, or even another language. So now that you have seen a few examples of machine learning, like we have gone through certain examples like regression, classification, clustering, style transfer. Let's go through some other examples, and you can tell me like which type of machine learning best describes it. I say best because some problems can be solved using multiple approaches. It's not like regression is suitable for this problem. It can be regression as well as classification. It depends upon the point of view from which we are looking at these problems. So we'll be discussing some of the examples, and I hope you all will participate. But participate means thinking in your mind and like getting to a particular answer before I reveal the answer. Uh, so the first example that we are discussing right now is recommending what someone will download based upon his previous purchases. So which is the best thing that we can use here? Is it classification, clustering, regression, sequence prediction, style transfer? So the answer is sequence prediction. Like while all examples of machine learning involves previous examples, this is an example of predicting the next thing a person will do based upon the previous similar sequences the model has learned from. So the correct answer is sequence prediction in this case. Next is uh, labeling email as spam or not spam. We have discussed this in the discussion as well. So it's very simple, and it's the most important example of machine learning algorithm, that is classification. So when the goal is to output discrete prediction labels like yes or no, spam or not spam, so this is a good fit for classification problem, I would say. Next is identifying trends amongst a group of people who have brought a new music release. Take some time and think upon this as a solution. Like what could be the probable machine learning algorithm that we could use here? So the answer here is clustering. Once again, the goal of this problem is less about making a specific prediction, but looking for similarities and finding clusters, trends, groupings based upon something in common. Captioning a video, how you're captioning a particular video. Like you might have seen this very common process in your video streaming sites, on YouTube, like anywhere. So the thing here we are using is a style transfer. Why style transfer? Because when the type of data generated by the system is different from the input data, then it's an example of style transfer. Like the input data is something in the different form and the output is in a different form, then we are using style transfer. So in this example also, the input data is video or an image frames. They are translated into text describing what is depicted in the image. Next is determining workout activity based upon phone movement. So it can be a bit tricky, like from which point of view you are thinking upon this questions. Pause a bit, think upon the same, and then we'll continue. The answer in this case is again classification, because example explanations could include what how we can explain this thing. Like the goal is to output discrete labels such as walking, running, jumping, which makes this task a good fit for classification. Like it's possible this could be determined without machine learning, but there would be so many situations where a person could be working out but instead driving a car. So how would you improve a machine learning system to better understand the difference? We can ensure that our system is trained with lots of examples of driving or bicycling. So this is something like you will know it better, true, positive, false, negative. So whenever we'll discuss it in a better way or in the intermediate or the advanced track. So this is the beginner track we're currently studying. Next is predicting the strength of a password. Try to think it from a different perspective. Like we can, if you can use two machine learning approaches for solving this problem. So it can be, I would say, classification or regression. So when the output of the machine learning system is a continuous number, such as your password is 50% stronger than the another, then it's a regression problem. However, users might prefer to take only the thing like whether the output was weak, whether the output was strong. So it can be like from different perspective, like how we are predicting the strength, whether it's in the form of a number or whether it's in the form of weak or strong password. So it can be both classification as well as regression. Identifying famous landmarks in a photograph. Just take 2 minutes. So again, this is an example of classification, like when the output is a discrete label, such as Eiffel Tower, such as Taj Mahal, such as Great Wall of China, Statue of Liberty. It's an example of classification. Suggesting spelling corrections. Clustering works in this space, like because words which are misspelled may end up closer to the correct spelling than a completely different word. So we'd be clustering uh, these things because misspelled words tend to be closer to the intended word. Like if for example we are spelling a particular word, so the wrong spellings will be closely linked to the correct spelling. So in another word, it can be described like it is possible to build a spelling checker using traditional approaches, but they would be complex, of lower quality, and need to be adapted to a new words and slang. So clustering approach is the best approach that fits here. Predicting the quality score for an advertisement. So whenever the word prediction comes, like how we're predicting upon the basis of number of labels, so which is the best approach that I've told you? It's a regression again. Estimating arrival time based upon the day and traffic. Estimating arrival time based upon the time of day and traffic. So what can be the best approach that we can, again, estimating, we are predicting something on the basis of certain things. So the answer is a regression in this case. The output of the system is a numerical value such as 1 hour or 5 minutes and all. Cool. We're moving upon to the end of the slides. Like this is probably the last second or the last third slide. So translating between two languages. It's again an example of clear example of we are inputting something and we are getting something else in the output. So what could be the better approach for this problem? It would be style transfer in this case. So I hope it's clear and you all have got some better insights into what machine learning is, and you will be able to answer these questions very well. What is machine learning? What is machine learning approach versus rule based approach? How we are implementing machine learning? What is AI? What is ML? What is deep learning? We went through the history of machine learning and we learned upon types of machine learning, whether it's classification, clustering, regression, sequence prediction, and style transfer. So this is all as of today's beginner session is concerned. For all of you, I'll be posting the post workshop survey form, and I hope you all enjoyed this session and you'll be attending the intermediate and the begin advanced track sometime somewhere, and to get to improve on these things, and you'll start with your preparation and you'll be starting with your data science thing soon. So I'm sharing the link of post workshop survey form. Filling this form, you'll get to know some insights into how the session was and what have you learned, and on the basis of these responses you will be getting certificates from us also, and it will help us to better improve our program, and we can, so that we can include the things that you want us to include. That's all from my side. Thank you so much. Thank you so much, everyone. I have shared the link for the post workshop survey form. I want all of you to fill this.
Thank you so much, Arsh. So now we are open for questions. If you have any questions, please post in the chat box. Okay, I have one question myself. What
Yeah.
are the what are the some algorithms that a machine learning engineer should know?
First of all, if a machine learning, we talk about a machine learning engineer. So it's a broad term. Like we can't narrow down to certain algorithms that a machine learning engineer should know. So algorithms, it can be like there are a lot of algorithms. Like in this session, also we discussed some of the algorithms like classification, clustering. So these are very beginning algorithms. Like the session was for the beginners, like
Yeah.
who have started with machine learning and they had no previous background of machine learning. So when we move upon from learning these algorithms, then we move on to some higher concepts. Like when we move on to intermediate track or advanced track, you will see there are certain algorithms. Like in the case of neural networks, there can be RNN, it can be CNN, it can be generative adversarial networks. So these are some of the other algorithms that we generally use when we are dealing with machine learning. But more than algorithms, so what I focused upon this in this session was like we should the important part is data pre-processing and data exploring. So if we have good amount of data and we have trained that data in a particular way, applying an algorithm is not that difficult task. Getting the data, exploring the data, cleaning the data, and working upon that data is the major part, and applying that algorithm is the second part. I hope that's clear.
Yeah, it is. We have one more question from James. What kind of opportunities are open to me in India as an ML engineer? I've heard it's a bit tough to get into.
Yeah, James. Hi, James. It's good to know that you are exploring opportunities in machine learning in India. But as far as I would say, if you are like looking out for opportunities after your btech, like after your bachelor's, then it's a bit tough. But as soon as you pursue your post graduation or your higher education in machine learning or deep learning, then you have a lot of opportunities in machine learning. Because companies, like if you're looking forward to join a particular company on the basis of your machine learning knowledge, so the companies are preferring people who have taken higher education or who are post graduates or who have done their phds. So as a bachelor, like we don't have enough knowledge to get into a company as a data scientist. So I would prefer, like if you are very interested in machine learning or deep learning, so try going for higher studies, and after that you'll have a lot of opportunities in this field. So this field is full of opportunities and it's a booming field, and you'll see to it whenever you see to it when people complete their post graduations, they have a lot of opportunities in this field. As far as for freshers in India, it's not like companies are not recruiting on the basis of machine learning. For that, you need to be perfect with your fundamentals, your data structures, algorithms, and your programming stuff as well. So I hope I'm clear with the your question.
Yeah, you're very much clear. We have another question from Shivraj.
um Machine learning role and opportunities in mechanical engineering. I would say it's not the branch that matters. Like if you are from a mechanical branch, and if you have significant interest in machine learning, so try exploring this field in all the possible ways. Try competing in competition. Like if you're just starting from very beginning, try to learn as much as possible how the things are working. Try to work upon some hands-on projects, how the things are working. Try to participate in challenges on Kaggle. Try to participate in challenges that are being held by various companies in data science and machine learning. So as soon as, like at the end, what matters is your skills. It's not your branch or your college which you are from. It's the skills that the companies look for. Like if you are skilled, if you are talented, so you'll get a certain opportunity in very good firm or a very good company or like whatsoever you're looking for. So this is just a misnomer that you are from mechanical engineering and you're not like what can be the roles and opportunities. So roles and opportunities are similar what is for a CS and IT guy, and it's similar to what a machine learning engineer will be having. uh, and I'll be more than happy to see like if people from other branches are also exploring this field, because there are a lot of opportunities in this field, and it can you can all leverage these opportunities.
I hope that clears your doubt, Shivraj. So I think that's all. We
Yeah.
don't have any more questions. So thank you so much, Arsh. It was a very informative session. I hope everyone enjoyed it. So
Thank you so much, all the participants and the whole team of DSC, Astha, Shivraj, for having me here and for this wonderful session. Thank you so much. Bye bye.
thank you so much.